All right, let's start. So hello, everyone. Today I will talk about the gRPC API protocol. We'll try to discuss in general what options and opportunities does it provide to you as the developer. And we'll try to delve in some more specific parts as the, for example, encoding. And I will try to share my specific experience that I had using gRPC. So yeah, quick introduction. My name is Anton Kuklin. I'm currently working as the senior software engineer in a company called TikTok, which you probably know. And more specifically, I work in the ByteDance, who is basically the owner of TikTok. And I work in the anti-fraud team, basically as the backend engineer. And we're working with some low latency, real-time inference to ML models and all the infrastructure around it. Generally speaking, I have more than 6 years of experience in the backend development. All those years I was working with the distributed systems, and most of the time I was writing using the Golang. Yeah, that's pretty much about me. Yeah, as I mentioned, we'll have a few sections today. First, I will start with the quick overview and the background, some basic definitions that we need to know to explore this topic. Then we'll talk about the Protobuf, which I will tell you what it is. Then we'll try to discuss some gRPC functionalities, and by the end, I will try to share some personal experience that I had using the gRPC. All right, let's start with this. So, as you can imagine, gRPC is most importantly an RPC protocol, and I believe we should, ask ourselves what is an RPC. Basically, RPC is just a remote procedure call. And again, what is the remote procedure call? Imagine you writing your code and you have a function. I don't know. Let's say create user, which basically goes to the database, inserts some rows, generates some SQL queries, etc. Basically, the RPC is an idea that you can execute this functionality remotely, but from your code perspective, you will just call this function. So basically, it means that it is just an abstraction, which removes from you all the idea with network communication, execution, and some remote server place, whatever it is. So yeah, this is basically the RPC. Yeah, as I mentioned, this is a client-server call based on the request and the response. And the main profit is basically this specific abstraction, which is, a crucial part of the distributed systems and generally any, computer science part. But what is the gRPC? First of all, it's made by Google, which actually justifies the first letter G. Second, what is really important, it is based on the HTTP version 2. I will cover just on the next slide why it is important, basically what's the difference with the second version of HTTP. And third, it actually uses Protobuf, which we'll discuss later on, as the IDL. And actually not specifically, you're not forced to use specifically Protobuf, but this is something that you will most probably use. And is part of the ecosystem of gRPC in general. All right, so what's so special about using the HTTP version 2? So first of all is binary. So, obviously any information, any data that you store in the computer is binary, right? But the point is actually, in our case, binary is the representation that you pass. It's basically having data not transformed as the plain text to, 0 and 1s, but forming frames of them. And I will show later on with the Protobuf an example, like how exactly it might be performed, what's like specifically binary is, right? So this allows us to have some sort of the definition of how we can structure specifically our data and not just writing strings or basically text as it was in HTTP 1 with, header, then new line, body, etc. An idea that this is binary allows us to use the multiplexing, which means that we can actually not only pass, one request to the TCP connection and then wait then for response, wait a few seconds while the server will process this request, or sometimes even more. But actually, we can pass multiple different queries in one TCP connection, again, due to the fact that it's binary and it's composed of the frames. And moreover, we can pass one part of the one request, then one part of the second request, and vice versa. So this is like a killing feature of the HTTP2. Due to the fact that we can multiplex our requests, we can reuse one TCP connection. We are not forced to, but we can reuse one TCP connection, which again is some sort of the optimization that speeds up and reduces the resource usage, etc. And the fourth point is the headers compression, which wasn't presented in the HTTP version 1, and currently it's presented in HTTP version 2. There are a few more points that are different from HTTP 1, but I right now listed only things that we will care about talking about the gRPC. So yeah, the first crucial point of the gRPC was the HTTP version 2. And the second one is actually the Protobuf. So let's discuss what the Protobuf is. As I mentioned, most importantly, Protobuf is the IDL. And the IDL is actually interface definition language. So basically, it's the way we describe some interface, some structures, messages, requests, responses, etc. Secondly, it doesn't depend on any specific programming language, which means that when you write your specific, interface, you describe functions and procedures that will be available, and the requests and response, you don't need to think about specific language, and you should not do that. Third is basically it's also binary, which actually we'll look into more specifically later on. And the fourth point is basically there is the code generation available based on your IDL, which means that you first usually write some sort of the IDL, which I will show later on how it looks like. And you have a broad number of tools to generate both, clients, server side for almost most languages that are available, and obviously C++, C#, Java, Golang, etc. Yeah. So you don't need to think about, how to call something physically using the network, etc. Everything is generated. So let's try to look into some basic schema of how the Protobuf file will look like of the service that you will write. We can see that basically we have 4 parts. The first one is the service by itself. And in our case, it's just the user service. And it has a definition of some procedure, function, endpoint, whatever you want to call, which is register user, which actually has the definition of the request and the response. What also we see? We see the definition of how we can define the messages, the register user request, register user response. And there are a few interesting points here. So first of all, you can see that each field in the messages has some sort of the ID. In this case, name has 1, like in response user is also ID 1, etc. We will discuss later on why it's required. More specifically, when we talk about the encoding. For now, we just need to spot this nuance. So yeah, basically that's pretty much it. Pretty much readable. You just see the service as the same way you will write your code, usually using your programming language, right? Let's look into some more advanced, fields, features, and properties that you might use. Let's extend our user message. So as it was, there is the ID of int64, but also now we see there is some sort of the enum, right? Which of course I don't need to probably explain what is, which also has, some sort of the IDs, but it is more like, just some sort of the values. And also it's important to spot that here the enum is defined inside the message. So it's some sort of the nested type, which you can, use to define something being, inside your current message, like logically. What else we have? We have the optional parameter, which means that this specific field is not guaranteed to be presented. The specific usage of it, like later on we will generate your code, depends. But for example, in Go, the fields that are optional will be not just strings, but it will be the pointers to strings. So you can actually, distinguish if the field was presented in the message or not. Because like if it would be the empty string, you won't be able to understand whether it's presented or it's just the empty string. What else do we have here? We have the repeated field, which is actually just another name for the arrays. Also, we have a map, which is just a map, right? Hash map, nothing so special. What else is available but not listed in this example? You also can define type of any, which as stands any, and depending on the specific language, programming language, there will be different types of how you would use it. And also there is the functionality of one-off, which is basically will define that only one of specified fields will be defined right in the message passed. So as you can see, basically, this is pretty much as you would write normal definition of your classes or structures using your normal programming language, right? But still, it doesn't depend on any specific programming language. But the functionality is pretty much broad, right? Not maybe like not so broad as it might be in, for example, GraphQL, but still it's pretty much sufficient. So let's start with what the gRPC provides by itself, right? Not as the protobuf, but as the protocol. So first of all, the very basic thing that you probably want to see is just the unary, which means that you make the procedure call, which has one message as the input, and it will have one response message. Just like imagine REST API call, you make the request, you receive response. Pretty much makes sense, right? Nothing even needed to be added here. Also, there is the thing that's called client streaming. Is actually when you can provide first multiple request messages, and you will, after you will provide all of them, you will receive the one response. So it is some sort of the stream as the request. What is important? Basically, some sort of the spoiler. There are multiple streaming approaches available in gRPC. So, important thing: the order is guaranteed, and yeah, this is crucial actually. So yeah, some sort of the example of real usage in real world. So, for instance, the company called Lyft, which you probably also know, they were passing the driver, geolocation to the server and to the client using this strip. So just normal use case, because like it's something pretty much similar that you want to pass each, n whatever seconds, whatever it is. Pretty much similar, but vice versa. There is the service streaming, which accepts one request messages and returns multiple response messages. Let's try to, use our imagination a little bit. And this might be, let's say we are writing some sort of the game and we want to receive some sort of the actions that were performed by some NPC for some boss, right? So we perform some request and then we want to, frequently until something happens, receive those updates. And basically, also, there is an option with the bidirectional streaming when you can pass in any order multiple. In any order, you can first pass, 2 requests, then receive 4 responses, etc. But not the ordering as you would send them. This order is guaranteed. Same idea. Basically, some gaming, some dual, multiple actions might be performed by the client. More or less actions might be performed and sent by the server. So yeah, pretty much it. So let's first talk about the why hypothetically you might use the streaming. First of all, it might be sometimes more performant, and but the problem is first of all, it's only on a large scale usually, as the practice shows and the materials that I have read. So you would think twice if you want to use them. And this is actually the deep topic, but as you can imagine that you have, I don't know, thousands of different pods or instances of the server. And the fact that you will pass the stream of messages means that you have to do it with one specific service from the very beginning, and you can't break this, not the connection, but the logical connection that you started, right? So this means that there is some restriction that you have to think about, and logically and physically also. And most importantly, reading the official documentation, you will see the post and the message and notification that don't try actually to optimize the protocol by itself, but try to logically, use the streaming when it's required by your business logic, by your application, right? As we discussed those cases, I mean, it makes sense to use streaming in those cases, but really try to avoid, to optimize it too much, overthink it, etc. It's really not about it. What else is provided by the gRPC out of the box? First of all is the authentication. Using certificates, using tokens, you can extend it on your own. So really you can experiment and extend it however you would like to do it. Second, there is such thing as the deadline. You can specify as the client the deadline in which the request should be performed, and basically you should receive the response. And as the server, you can handle this, check how much time you have left. Maybe you want to finish a little bit early if you understand that you won't be able to finish this workload in the specified deadline, etc. Third, there is the cancellation. So you can cancel actually the request if you do not require it anymore. So again, you will remove the obsolete executions on the server side. Fourth is actually the load balancing and the load balancing on the client side. Again, there are some strategies that are specified out of the box, but also you're absolutely available to implement it on your own and to extend it. And the last but not least is actually the metadata. Generally speaking, you can think about it as just the headers in the HTTP request, but it's a little bit more. So you can, again, if you would, for example, use Go, this metadata will be injected in your context variable. So again, it's some sort of the abstraction from you. So you don't need to think about this. These are headers or it's not a headers. It's more like the idea, some metadata that is passed during your call propagation. So let's hypothetically think where we can use the gRPC. So first of all, obviously, any server-to-server calls in your backend infrastructure, etc. First of all, efficient. Second, I mean, it's just much more easier to write your code, not thinking about again, talking about, for example, REST or some other protocols that you have to think about the networking and all the problems that lie behind it. Is just an abstraction. So you just use the generated code function, you fill the message, request, you handle the response, and that's pretty much it. Mobile application, same, right? A lot of companies are using gRPC for the mobile app backend calls, as I mentioned, Lyft, also Snapchat, as far as I recall, using this. So not much problems at all. But here is the problem with the web. And one of the most frequent questions that you will actually see when you will Google about some basic questions like gRPC versus REST, etc., is the problem is, first of all, as you recall, gRPC uses and forces you to use HTTP version 2. And there are some restrictions from the web browser, because, like, first of all, not all versions, I mean, I'm talking about the previous versions, support the HTTP version 2. So yes, most of the or basically almost all the versions, latest versions of browsers support HTTP version 2, right? But gRPC uses some specifics of HTTP version 2, which are not directly provided by the browser to be accessed using JavaScript. So the option to use the gRPC as from the web client is basically to have a proxy, which is called gRPC web. However, it's one more, simplification step, whatever you can call it, right? So it's something that you would like to think about twice, keeping in mind that, you will have one more layer that you have to maintain, that you have work on, etc. So which RPC alternatives really are presented? So first of all, of course, something that usually comes up is JSON RPC, which is actually just the way that you form the RPC, or like remote procedure call using the JSON as the fast request and response. Comparing with the gRPC, first of all, gRPC is the whole ecosystem that provides the functionality. And second, it's just not efficient, right? What's the point of passing JSON? The only point is really that you can, it's much more simpler. However, and you can actually, due to the fact that gRPC is the protobuf is binary, it's much more harder to, check what was, sent, what you received in the response. So you need to use more tools for that. And with the JSON RPC, you can just, check the request response. That's pretty much it. The second option is actually XML RPC, which is really, really old and uses XML as the, approach. So the problem is that XML is something really complex from the readability, and it's not so user friendly. However, I do understand that you can't measure or quantify the being user friendly or not. However, it's also an option, and it was long before the gRPC appeared, and also it supports the code generation. So hypothetically, you might want to use it. However, I don't see any specific reason or benefit of doing it when you already have gRPC. And again, due to the fact that gRPC, as I mentioned, offers the whole ecosystem around, and it's just the modern view. You will have the modern documentations, you will have the modern user base, so you can easily Google all the information, all the problems. And as I mentioned, gRPC is backed, or especially was backed by the Google. So it's something that you can be assured about. All right, so these were more likely the introduction of what gRPC offers. So right now we will try to delve a little bit deeper and look into how exactly the protobuf encodes the messages. And it will give you an idea of why actually it's more performant, more optimized, etc. It will be a little bit not so easy, so I will need your attention to actually look into the bytes and bits. So yeah, let's start. All right, so let's imagine that we have the some very, very simple user message, which has the age field of int64, which has the ID 1. And we basically define this structure, and we set age to 21, right? Let's try to encode this value. On the right side, you can see that the result of the encoding will be 8 and 21, which, basically this array is the array of bytes, but bytes are represented as the decimals, right? So, it pretty much makes sense, because 21 is just the value of 21, right? It's the age 21. And we can see two values which are basically key value, right? But the question is, why 8? Why 8 if our ID of the field is 1? And this is actually very interesting. Let's look into that. So here we come into the TLV, or tag length value problem. So the point is that those IDs are required to understand which field was defined, right? However, let's imagine that we had some sort of the server and the client, and server currently gets the new update of the message, and new fields are represented, which are not yet supported by the client. And the client doesn't have an idea of exactly how to decode this field, right? But still, the client should understand how to read this part of the message just to skip it, right? And this is the time where why we need actually this tag. And this tag represents the wire type, or basically the type of the next field. And there are multiple types. So the one that we are looking into right now in 64 is the var int, which actually means that we don't really need to use all the time all maximum amount of bytes to encode the int64. For example, if we have value 1, we can just use 1 byte. So we don't need to use more bytes. So this is an idea of var int. So in this case, let's look at the formula, how it works. So as we recall, the order is basically key value, and the key should contain the var type to understand how much data then we should read. And due to the fact there is the formula of how key byte is formed. So first of all, we are taking the field ID, and we are shifting 3 bits to the left, and then we are adding the var type. So in our case, the var type is actually 0. So we are having the field ID 1, which is shifted left to 3 bits, and then we have +0, which results in 8. And this is the reason why the encoded value is 8, but not 1. I do understand that it might be a little bit unobvious, but I will show later on also more examples of how it might be used and why it's used. Yeah, right. Let's move on. Let's look into the next example. So we'll extend our user message with one more field, which will be actually year of birth, and we will set, 1995, right? So on the right side, we can check the encoded value, which is again 821, which we already have looked into it. Then it comes 16. We can pretty easily understand why it's 16. Still, the idea was to, we have to shift bits 3 bits, plus it was 2, which was actually already 10 in the beginning. So it becomes 16, which, again, 3 bits, and initially it was 10. So, it makes sense, right? Yeah, I actually see the questions in the chat. I will try to address them by the end of the presentation. Right, but why is the last 2 bytes 203 and 15? Okay, let's look into the representation that we have. So first of all, the 203 starts with 1, which is important. So the first bit in the byte is the most significant bit, which means that if the first bit is 1, it means that this is the part of the big message, and the next part should be some sort of concatenated and used also as the current value, which will be result in the end. How can we calculate it? So basically, we can see that we have the 203 represented here and 16 represented here. So as I mentioned, so the first, yes, it will be recorded. Sorry to interrupt. Yes, it will be recorded and put into the YouTube so we can reproduce or basically ask the questions by the end. I will try to address them. All right, so let's get back to it. The first bit indicates that this is part of the whole message, and that we should, use this second part too. The 0 bit indicates that this is the end of this part that we are decoding. When we will calculate those, we will remove those bits. Sorry. So it will result in the same part without the first bits. All right. Okay, makes sense. But if we'll take this bits and we will decode them into the decimal part, it won't be 1995. This is due to the idea that the little endian encoding is used here, and it means that we have to write or read bytes in the worst order, which means that we have first place this part and then this part. And if we will, read them and decode in the reversed ordering, we will receive this 1995 actually. Okay, so again, the reason why I'm sharing the encoding techniques, etc., is basically we obviously won't cover everything, and there is no need specifically, but this is the just brief idea of how exactly it's performed, and we can look into it later on. But here's the example of how exactly you can use this knowledge of how it's encoded. So again, we are taking pretty much the same message, but we are adding the third field, which will have the ID 250. And again, we'll set 1, 2, 3, which means that we have 8, 1, 16, 2, which we already covered. But then again, we have this 2 bytes to cover the ID. I really don't want to, complexify it again and, torch you again with this idea of how the bits are moved and decoded, etc. You can, double check later on using this slide. But the idea is that, of course, the field IDs are encoded in the same way, using the most significant bit, etc. So this actually means that the maximum, and again, as you recall, there will be a bit shift on 3 to the left. So this means that the maximum ID that you can fit into 1 byte is basically 15. And here's the example. You can't use the most significant byte. And 3 first bits will be used for the value type, or basically the wire type definition. And as a result, the maximum value that you can pass is 15. So what does it basically mean? First of all, you don't want to put optional fields in the first 15 fields, due to the fact that if you really want to make something at most performant way, then you don't want to waste 1 byte IDs with the optional field. Okay. Yeah, and basically we are running a little bit late, so I'll try to speed up a little bit. So let's talk about my personal experience of the usage of gRPC, and it will actually more relate not to some specific gRPC points, etc., but more like the global approach and the problems or benefits that I faced with. So the first one is basically the GQL, which is basically the GraphQL gateway. So in one of the companies, we were using the GraphQL gateway as the gateway to handle the web requests, and inside the infrastructure and backend, composition and architecture, services were talking to each other using the gRPC. Obviously, it's pretty convenient, as I mentioned, in regards to the fact that you write the service by itself. You maintain the separate repository with the IDLs. It's really convenient when you don't really think about, again, creating new requests, like parsing the status of the request, like placing specific, I don't know, header, etc. So you are abstracted from all these things. However, there is some points. First of all, as I mentioned, let's imagine that we have the Protobuf definitions being placed in a separate repo. And let's imagine that we are adding the new endpoint, or basically the new, generally speaking, new endpoint on the GraphQL and the service. So let's count the pull requests that we have to perform. First of all, you will go to the Protobuf repo to update it with the new IDL fields or procedures, etc. All right, this is one. Second, you go to the service, and you have to basically implement this procedure. All right, seems nice. Then you go to the GraphQL, and you have to first extend your GraphQL schema with the new endpoint, with the new types, etc. Then you have to update the Protobuf definition and write the client, or basically extend the, by writing client, I don't mean the network communication center, but the logic, like you put in, requests, you're getting the response, etc. Right. Then due to the gateway specifics, you have to think about the throttling, caching, maybe roles, etc. So the process of adding the new endpoint or whatever, it's relatively long. And but this is some sort of the trade-off, right? When you want to, distinguish and abstract such things. All right. The second architecture that we have used in another company was basically services between each other were using the gRPC for calls, right? However, based on these specified protobufs and IDLs, there were libraries that were generating the REST endpoints. And we had some sort of the REST gateway, which, like, in a nutshell, it was just using some throttling, routing, and authentication, and just, injecting some headers and bypassing and forwarding the request later on to the destination service. However, like, this is the working schema, and there are a lot of benefits, and the disadvantages that we had related not to the gRPC, but to the overhead with the REST and the number of calls that we received to handle pretty much specific endpoints, etc. So I would say this is also something viable, and this shows basically that you can use Protobuf not only to describe the gRPC endpoints, but also to, for example, generate REST endpoints based on that. Yeah, so also something that, like, some profits that you might receive using the gRPC and the Protobuf as the ecosystem. First of all, again, usually what we have done and what you can do is basically use Protobuf also for MQP messages. You can describe it in the same place. You can use in like the end services different languages. One service might be on Go, second on Java, third on C++, and you will still able to generate the structure classes for those messages that you will put in the MQP or read, etc. So this is something really convenient. And obviously you can use not only, depending on specific MQP, but sometimes you can even encode the Protobuf into the binary and put it into the MQP or basically any event system. Something to think about and that you have to remember about. Those field IDs, optional fields, field types, it's something that you have to really be careful about, because in case you will change the field ID or you will make some field optional or something like that, or hypothetically you will, by some reason, you will change the field type, which you hypothetically could do in other protocols like REST. You will break basically the existing clients, and you most likely you won't be able to update them at the same time, right? You won't be able to deploy the latest version at all the places. And so of course there are plugins and functionalities to perform such check of compatibility in the CI, but it's something just to keep in mind. Yeah, so basically, let's quickly wrap it up because we are really running out of time. So first of all, yeah, gRPC is something that will definitely fit for your S2S or mobile communications. Not something probably, arguable, but not something that you will think about for the web. Especially, actually, talking about the web, usually there are some subset of endpoints that you want to provide to the third-party users for integration, etc. And it's pretty much complex. And usually people want to integrate such things as easy as possible, making understandable, HTTP/REST call, etc. So this is also something to keep in mind. However, there are a lot of benefits that we discussed that brings the fact that you use the gRPC ecosystem in general, which is for example, define message from MQPs, generating REST endpoints based on Protobuf, etc. Yeah, I guess that's pretty much it. Sorry, it was longer than I expected. I will be glad to answer your questions. I saw that there were a couple of them. Yeah, good question. So I will read the question. How is error handling done with gRPC? Since typically with the REST, you might rely on the HTTP status codes. All right, yeah, good question. So first of all, there are status codes also that provided by gRPC, but sometimes this is not enough, and you can actually, pass your own. First of all, you can pass also not only the status code, but also the message, right? Your custom message of the error, etc. However, there are a few works and few approaches that people sometimes want to use some more complex error definitions, etc. This is also the case. Plus, you can recall the fact that there is the metadata, etc. So there are ways how you can handle this, but out of the box, usually you have also the status code, and you also have the way to define the error message. I guess these are all the questions from the chat, so I will be glad to answer your more questions. All right, I guess then that's it. Let's wrap it up. Thanks for coming. I left here my contacts. You can add me on LinkedIn or follow me on GitHub. I will be glad to stay in contact. And yes, reach out to me if you have more questions or discuss something. We'll be glad to communicate and help. Thanks. Have a nice day. Bye.